Well, thanks very much, Steve. I also want to thank the Cabot Institute and the University of Bristol for being wonderful hosts. It's really a pleasure to be here, to be participating in this workshop that we had over the past few days, and to now have an opportunity to talk to you about one of the foremost issues that we face today as a society, dealing with the issue of human-caused climate change. So thanks to all of you for coming out on a Tuesday evening to hear me talk about that subject. I'm going to talk about climate change from a particular perspective. As Steve already described, I published this graphic a decade and a half ago. It's come to be known as the hockey stick. And little did I realize that in so doing, I would eventually find myself in the center of the larger debate over human-caused climate change. It's not what I expected. It's not what I signed up for when I double majored in applied math and physics at UC Berkeley, but it's where I found myself. And I'm going to try to share some of the lessons that I think I have learned from my somewhat reluctant and accidental arrival as a figure in the larger debate over climate change. The first point I want to make is that the actual scientific case is fairly straightforward. We often hear, we read in the media, when we listen to discussions of climate change in the public discourse, it sounds like it's a contentious issue. But fundamentally, the science, the basic science behind global warming, the greenhouse effect, it's not new controversial science. It's basic physics and chemistry we've understood for nearly 2 centuries. Joseph Fourier, back in the early 1800s, the same Fourier who discovered the Fourier series, Fourier's theorem, the law of heat conduction, he understood that there was a greenhouse effect. And over the past 2 centuries, of course, we've been refining our understanding of the details. But the basics here, the fact that certain gases in our atmosphere, like carbon dioxide, warm the planet, is not contested. It's not controversial. We've known about this for a long time. The fact that we're increasing the concentrations of these gases in the atmosphere, again, is not contested. It's not controversial. I do have to point out, like with several of my graphics that I prepared a couple years ago, they're already out of date. In this case, the CO2 curve is so out of date that you have to draw a new vertical tick mark to show the current level. We've just crossed 400 parts per million CO2 in the atmosphere for the first time, we think, in millions of years. So we are engaged in this unprecedented experiment where we are bringing the concentrations of these gases to levels not seen over the course of human civilization and beyond. That's all you need to know. The greenhouse effect, basic physics and chemistry. Greenhouse gases warm the planet. We are increasing the greenhouse effect substantially. What I wouldn't be able to explain to you as a scientist would be if the Earth were not warming up as a result of that. But of course, we know that the Earth is warming up. It's warmed up a little less than 1 degree Celsius thus far. Now, there are critics. I think there might even be a few of them in the audience. I don't know. There are critics who don't believe the surface temperature records. So we could get rid of the ocean measurements, which tell us the globe is warming, the independent land measurements that tell us the globe is warming, all of the thermometer measurements. I could show you dozens of independent lines of evidence that tell us an internally consistent story of a planet that's warming up and a climate that is changing, much as we expect it to as we continue to increase the concentrations of these gases in the atmosphere. And that's the sort of evidence that has led the very conservative body, the Intergovernmental Panel on Climate Change, hundreds of scientists around the world who get together and over several years draft a report that represents the scientific current state of understanding of climate science every 5 years or so. And the most recent report, the 5th assessment report published just over the last year, the IPCC concluded that the warming of the climate system is unequivocal. Okay, scientists aren't debating this. If you go to a scientific meeting, you won't find scientists debating whether the Earth is warming. If you read a peer-reviewed journal, you won't find articles questioning whether or not the globe is warming. Now, that is accepted. It's unequivocal. And this is, again, Again, a conservative body, the IPCC reflects sort of the lowest common denominator of what hundreds of scientists can all agree upon. And by its nature, it therefore tends to be a conservative assessment of the science. It's rare that scientists use words as strong as equivocal, and that's telling. Now, none of that is based on climate models. The critics will often sometimes complain. They'll say, well, global warming, climate change, it's based on these untrustworthy, unvalidated climate models. And that's doubly wrong. And I'll describe the second reason why it's wrong shortly. But it's not based on climate models. I already showed you the evidence for human-caused climate change. Fundamental physics and chemistry we've known for 2 centuries, irrefutable measurements telling us we're changing the composition of the atmosphere, and the globe is indeed warming up as we expect it to in response to that. But we use climate models because we are engaged in an unprecedented and uncontrolled experiment. If you want to test different hypotheses about how the climate system responds to different factors, both human and natural, then really the only way to do that is to formalize our physical understanding of the system. And I say physical, well, there's the physics of the atmosphere and the ocean and the way they interact, but there's also chemistry, the chemistry of the carbon cycle, the chemistry of greenhouse gases, and there's biology as well. And we formalize our understanding of each of these components and how they interact in the form of a mathematical model. That's what a climate model is. Now, you might be wondering, I realize this is a UK audience. I don't know if you all watched this show when we were watching it back in the 1990s. Anyone recognize that? The Seinfeld restaurant. Why am I showing you the Seinfeld restaurant? Okay, a reasonable question. Well, in the upper floors of this building, the Upper West Side of Manhattan, 3 years before the Seinfeld show went on the air, 1988, Dr. James Hansen, the former director of the NASA Goddard Institute for Space Studies, which is located in those upper floors. I did a sabbatical there back in 2004. I got to go to work at the Seinfeld restaurant every day. It was sort of fun. Well, Hansen was doing experiments, was making predictions with a climate model that, by today's standards, was quite crude. And as Niels Bohr once famously said, predictions are hard, especially about the future. And that's what Hansen did. He made a prediction about the future back in 1988. Here are the observational temperature records, the globe as recorded by thermometers, how it had been warming in the decades leading up to that prediction. And he ran his climate model 3 different times, and you can see each of those simulations. They're not identical because just like we have weather, noise in the atmosphere, the climate has its own weather, El Nino events, random events that come and go. And so if you start your climate model 3 different times with 3 different initial conditions, you won't get an identical trajectory, but you will hopefully capture the main signals. In this case, the signal of global warming that was evident thus far, and then he projected into the future under 3 different possible scenarios. After all, James Hansen couldn't have predicted human behavior, what we would choose to do. Would we choose to greatly curtail our burning of fossil fuels? Would we choose to greatly accelerate our burning of fossil fuels, the green, beyond the historical trajectory? Or would we fall somewhere in between? And it turns out we've fallen somewhere in between in terms of our actual fossil fuel burning, other human activities. Arguably, the scenario we've actually followed is closest to B, somewhere between B and C. And that's the prediction for scenario B. That's what actually happened. Okay, and you can quibble about the details of the instrumental record and which records are used and which particular scenario you use, but it's pretty clear that Hansen made a successful prediction of global warming decades into the future. I would say that that's a pretty impressive prediction. Now, if you're a critic, and again there are critics, you might point to this dip in temperature that happened in 1991, 1992, and you might argue, well, if these climate models are so great, if they're so trustworthy, then why is it that the climate model couldn't predict that huge cooling in 1991, 1992, 1993? And it's true that James Hansen didn't know in 1991, in 1988 rather, that in 1991 Mount Pinatubo would erupt. And when it did erupt, it put large amounts of reflective particles in the lower stratosphere, blocking out some of the sunlight for several years, cooling the planet. What Hansen did know is that it actually takes a number of months for that volcanic cloud to spread around the global stratosphere and begin to have a cooling influence on the surface. So he had time to run another experiment, feeding the climate model the estimated distribution of these volcanic particulates and predicting what would happen. And the model predicted that the globe would cool about 0.5 degrees for several years. Turns out what you might have thought was a flaw in the climate models was actually an opportunity for another successful prediction. And I could bore this audience to tears discussing the hundreds of pages of model validation exercises, much more mundane validation exercises described in the various reports of the Intergovernmental Panel on Climate Change. Suffice it to say, there's reason to take these models seriously. There's reason to think carefully about what they have to say. And so we can use those models, again, to test hypotheses. After all, we saw that Mount Pinatubo had a big cooling effect. And so if there's a change in the frequency and the magnitude of these volcanic eruptions, well, you could get a temperature trend. So maybe it's factors like volcanoes. They're small but measurable changes in solar output, another natural factor that influences the climate. So you might rightly hypothesize that, well, hey, maybe it's those natural factors that are responsible for the warming that we've seen over the past century. Well, we can test that with the climate models. And when we put the natural factors into the climate models, the models on the whole actually want to cool slightly, at least through the late 19th century, late 20th century. And that's because solar output has been flat or even slightly declined in the recent decade. There have been a relatively large number of explosive volcanic eruptions, El Chichon in 1982, Mount Pinatubo in 1991. You put those natural factors together, the prediction is the globe should have cooled during those decades. And it's only, in fact, when you increase the concentration of greenhouse gases in the atmosphere that you are able to explain in the models the warming that we've seen. And in fact, we're able to explain not just the overall warming of the globe, but the detailed patterns of where the globe has warmed, the surface, the lower atmosphere, the upper atmosphere, the pattern of warming. And it's this sort of evidence that has led the IPCC, essentially, again, a very conservative body, in their most recent report, to conclude that human influence, or I should say, it is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. That, again, is remarkably strong language. Extremely likely is a very high degree of confidence, roughly tantamount to 95% certainty. And note, they're not just saying human influence has been a cause of global warming. It's been the dominant cause. And in fact, if you read the technical chapters of the IPCC report, what you'll actually find is that human factors or increased greenhouse gases in particular are likely responsible for more than 100% of the warming. And how can I say that? Well, other factors, natural factors, and other human factors like pollution through the mid-19th century before we we passed Clean Air Acts in the US and here in the UK to remove the pollutants that in some places were having an offsetting cooling. In spite of those other cooling factors, the globe has continued to warm. We can only explain that warming from increased greenhouse gas concentrations. So let's use those models now and try to look into our future. Well, again, that's difficult because we don't know what we'll choose to do. If we could somehow magically freeze CO2 levels at their current level, the globe would continue to warm, it turns out, for a number of decades, just because of the warming influence of the CO2 we've already put into the atmosphere as it continues to penetrate into the ocean and warm the ocean. But we would likely avoid warming more than 2 degrees Celsius relative to pre-industrial. Now, why is that an important number? I'll come back to that. If we, on the other hand, continue with business as usual, fossil fuel emissions, then we're probably somewhere in the range of 4 to 5 degrees Celsius. For American audiences, I do the translation to Fahrenheit. I'm not going to bother doing that here. 4 to 5 degrees Celsius, 8 to 10 degrees in the Arctic because of the amplifying factors associated with the melting of ice, of sea ice. 8 to 10 degrees Celsius warming of the Arctic, 4 to 5 degrees warming of the planet, more warming than that 4 to 5 degree average over land, because the land warms more than the global average. The ocean warms less than the land. That is, in the words of James Hansen, who I mentioned earlier, it describes a different planet. Now let me just say something about that 2-degree warming. This is from the most recent impacts report, the second working group report of the Intergovernmental Panel on Climate Change, published months ago. And it shows this measure of the severity of various impacts on climate change as a function of the overall warming of the globe. And what you can see here is once you get above about 2 degrees Celsius warming relative to pre-industrial, you're really starting to get into the red. By these various metrics, we're starting to enter into what might reasonably be described as dangerous and potentially irreversible climate change. Well, I wrote an article earlier this year, Scientific American, where I talked about that 2-degree limit, and what I showed is that we could still take the actions necessary to avoiding crossing that 2 degrees Celsius warming limit. But it becomes increasingly difficult with each year of inaction. And if we continue with business as usual, then again, we're talking 4 to 5 degrees warming of the planet by the end of the century. And as I said, that's a different planet. It's not the planet that most of us grew up on. And images, better than words, I think, capture some of the changes that we're potentially talking about. Now, I used to end with the polar bear, because it's actually a law in the US. If you give a talk on climate change, you have to show a polar bear. And I realized that many of us, by making the polar bear sort of the poster child of climate change, were sort of inadvertently sort of misrepresenting what climate change really means, because polar bears, they seem far away in space and time. They're very exotic, they're very abstract. It's hard to really connect your own experiences with the experiences of polar bears up in the Arctic, potentially decades from now. And so everywhere I go and lecture, I try to convey now how climate change is impacting where we live right now in various ways. I gave a talk in Central Texas a year and a half ago. It turns out the town where I gave this talk, San Angelo, is the home to this lake, or I should say former lake. They used to call it Lake Fisher. It dried up in the 2011 Texas drought. It's gone now. I lectured in Portland, Maine a few weeks later. It turns out the iconic species of Maine, the moose, and also the lobster, the other iconic species of Maine, which is moving northward as waters warm, threatened by climate change. Northwest Missouri, sort of the heart of the 2012 Midwest heat wave. And what this shows is that record heat, what we would describe as record heat in Northwest Missouri, now, in a matter of decades, if we continue on this course that we're on, will be a typical day, midsummer day in Northwest Missouri. The hottest day we've experienced yet will eventually become a typical day. California, when you go to California, you don't have to convince them that climate change is real. They're seeing it right now in the form of the worst drought on record, by far the worst drought that California's ever seen. And we can talk about the various components of that drought where climate change is likely a contribution. The banana slug of Santa Cruz. I gave a talk at Santa Cruz, UC Santa Cruz. That's their mascot, the banana slug. Doesn't look particularly appealing here, but it's a magnificent, unique creature. And the redwood forests that are home to species like the banana slug are a fairly fragile environment on the coast of Florida. It doesn't take a very large shift in atmospheric circulation patterns and ocean surface temperature patterns to fundamentally shift that the climate there that currently supports these redwood forests. And so, in fact, the banana slug, there are articles talking about how the banana slug could indeed be threatened by climate change. I gave a talk down in Florida. And Florida, they have this seasonal tide. It's called the king tide. Every year, You get, at certain times of the year, you get a high tide. But it didn't used to be the case that the king tide flooded the streets of Miami every time it arrives, which it now does, as sea level slowly increases. And that's how we're going to see the effect of sea level on our coasts. The extreme events are going to become more extreme. The high tides are going to become higher. It isn't just going to be some gradual inundation. We're going to see it in scenes like this, playing out across the globe in coastal locations. I gave a talk a few months ago in Utah, where their water resources are fundamentally threatened and where their skiing industry could be threatened. They're actually quite worried about that. It's an important part of their economy. Where I live in central Pennsylvania, we were not immune to the effects of the 2012 heat wave. There were lives that were lost in Pennsylvania because of it. And again, the extreme heat that we saw during that heat wave, the climate models tell us, will become typical midsummer days by mid-century if we continue on this course that we're on. The UK, well, you know something about heat waves here. 2003 heat wave was a record heat wave. It was a large loss of life. By some estimates, it was a heat wave that shouldn't have happened in hundreds of years if it were just for natural variability. It was made much more likely by climate change. And in that sense, scientists have concluded that we can attribute the 2003 heat wave. It was much more likely to happen because of the warming of the globe we've already seen. So, already giving a glimpse of the sort of future that's in store for us. Now, it used to be that I would talk about the 2003 heat wave in Europe because it was the best example of this phenomenon, but we don't have to do that anymore because, well, I'll come back to that in a moment, actually. Let me first talk about one other event that I think those of you who live here in this part of the UK were quite aware of and experienced in a very negative way. The 2014 flooding event, a winter flooding event here in the UK, in the lower UK. Even the UK Met Office, and I know it's a controversial statement, but one of their scientists said, you know what? This is exactly the sort of event that we have been saying is becoming more likely because of climate change. It was unlikely to happen in the absence of climate change. So yes, there is a link with climate change and this extreme flooding event, and we're going to see more of that. Now, so at this point in the lecture, this is where I ask, rhetorically, really, if the evidence is this clear, climate change is real, it's caused by us, it represents a threat, why is it that we've taken no meaningful action yet to truly combat this problem? And that, of course, forces us to leave the realm of science and get into the realm of policy and politics. And fundamentally, the answer to that question lies in the fact that we are a world that, in the words of former Republican President George W. Bush, is addicted to fossil fuels. Okay? We get our energy from fossil fuels, by and large. We are addicted to fossil fuels. There are vested interests who profit from that, and understandably, they don't want to see that change. And we're asking for substantial changes for no longer continuing with business as usual. Well, back in 2002, there was a memo that was leaked by a Republican pollster, Frank Luntz. And among other things, what he said was that there was this shrinking window. The public was becoming convinced that climate change is real, that there is a scientific consensus behind human-caused climate change. And if they become convinced that there is a consensus, they will demand that action be taken. But, he said, based on his focus groups and his polling, there was still a window of opportunity left to insert doubt into the public mindset, to create confusion, he actually advocated establishing think tanks, front groups, paid advocates, whose role was to fundamentally confuse the public about the degree of scientific consensus that exists. Now, at this point, you might be saying, where have I heard that before? That sounds so familiar. Well, it's what the tobacco industry did decades ago. And it's the same playbook that certain fossil fuel interests, I should say, are playing by now. And the linkage between the denial of human-caused climate change and the denial of health impacts of tobacco, the history behind that linkage is described nicely in this book by Naomi Oreskes and Eric Conway, Merchants of Doubt. And in fact, something you may not be too surprised to learn is that not only is it many of the same organizations, but it's some of the same paid advocates, scientists with impressive-sounding credentials, who are now paid advocates for the fossil fuel industry who used to be paid advocates for tobacco interests in denying that problem as well. And so it's for reasons like that that we have powerful politicians, James Inhofe, who may become the chair of the Senate Environment and Public Works Committee if the Republicans regain control of the U.S. Senate in this next election, said back in the summer of 2011 that basically that climate change is the greatest hoax ever perpetrated on the American people. And somehow we scientists have managed to collude, hundreds and thousands of us, and we've gotten the oceans and the ice sheets and the atmosphere to play along with our hoax. As Naomi Oreskes once said, we should be so organized. Anyone who knows scientists knows you get 3 of us in a room, you may have difficulty getting us to agree on just about anything. The idea that we would all conspire to create an elaborate hoax, well, James Inhofe thinks it's true, and he was still proclaiming that in the summer of 2011 when the Heartland Institute, which is an industry-funded think tank, was funded by tobacco interests in the past to deny the health impacts of tobacco. Today, they are working for fossil fuel interests to deny human-caused climate change. James Inhofe had been invited to be the keynote speaker that summer, July 2011, at the Heartland Institute's annual conference. Unfortunately, he had to back out at the last minute. He had gotten ill swimming in a lake back in Oklahoma that was suffering from an algal bloom as a result of the unprecedented heat and drought that Oklahoma was experiencing at that time. So he was unable to give that talk. How did I find myself in the center of this fractious debate? Well, we sort of already know the answer to the question. It's a rhetorical question. It's because of this curve that my co-authors and I published a decade and a half ago that came to be known as the hockey stick because of the dramatic warming that it demonstrates relative to anything that's seen as far back as we could go, 1,000 years. It got a name. It was featured prominently in the summary for policymakers of the 2001 IPCC report, and so it became an icon in the climate change debate. And as happens to icons in the climate change debate, as many of us know, they get attacked by those seeking to discredit the case for concern over climate change. And so our work has continued to be attacked. And it doesn't matter that there's a veritable hockey league. There's now well over a dozen reconstructions from paleoclimate data, which differ in some of the details. And those differences are interesting, but they all come to the conclusion that the recent warming really does appear to be unprecedented as far back as we can go. Now, there was one little monkey wrench that was thrown in to the situation about a year ago, a little more than a year ago. There was a new article published in the prestigious journal Nature Geoscience. Team of nearly 80 scientists from around the world using the most comprehensive paleoclimate database yet came up with a new estimate of large-scale temperature trends over the past 1,000 years. And as you might have guessed, they ended up completely overthrowing. Oh, no, I'm sorry. That's right. They got the same answer that we did a decade and a half ago. But it doesn't matter. The attacks do continue. And it doesn't matter that the IPCC has now come to even stronger conclusions that the recent warming is likely unprecedented, even further back, probably as far back as 1,400 years, as far back as we can confidently extend the record, maybe longer. But that doesn't matter. The hockey stick really has become a distraction in a sense, because it doesn't matter if there weren't a hockey stick or even a hockey league. You could get rid of all that paleoclimate information, and we would still know that climate change and global warming are real, they're caused by us, and they represent a threat. I outlined the evidence for that in the first few minutes of this talk, and it didn't involve paleoclimate data. But the hockey stick did become an icon of the climate change debate. And there were many who thought that if they could take down this iconic curve, in part by taking down its lead author, me, that maybe they could cynically argue that they've sort of discredited the case for concern over human-caused climate change. One might argue it's a pretty cynical approach. But because of that, we have been subject to what I like to call the scientization of politics. Sometimes people refer to the politicization of science. I actually think a better term is the scientization of politics. It's something that's even more pernicious. It's the way that science is now used as a political football, just another way of waging politics. And if you don't like the science as assessed by the IPCC or the US National Academy of Sciences or all of the national academies of the major industrial nations or all the scientific societies in the US and in Europe that have issued statements about human-caused climate change, all of which have come to the conclusion that global warming is real and caused by us. If you don't like all of that, if you don't like what the world's scientists have to say, well, there are tabloids here in the UK and back in the US. Hey, we've got a cable channel that you can watch that presents a completely different universe where the laws of physics aren't what we thought they were, where the greenhouse effect isn't real, global warming isn't real. Well, I wish that universe were real. I wish that climate change was just a figment of our imagination. The world would be a much simpler place. Our lives would be much easier, but that's simply not true. Nonetheless, we do have politicians like Joe Barton. He was the chairman of the House the House Energy and Commerce Committee back in 2005. That summer, I got a letter from Joe Barton. Well, actually, it was a subpoena. It was a congressional subpoena, basically, demanding all of my scientific documents, my scribblings on the back of napkins, everything that I had done in my scientific career, and the same materials for my two senior co-authors, based on the fact that he had read a criticism of our work in the hockey stick in that most prestigious of journals, Rupert Murdoch's Wall Street Journal, the editorial pages of the Wall Street Journal, and used that as an argument for an open-ended fishing expedition to demand all of my, scientific documents and scribblings, personal emails from my entire career. Well, it got a response, but perhaps not the sort of response that Barton was expecting. Scientific groups like the AAAS, publishes the journal Science, the largest member organization of scientists in the US, wrote letters. AGU, the American Meteorological Society, the journal Nature, all issued very stern criticisms of what they saw as an obvious attempt by a politician who, I'm sure it was just a coincidence, happened to be the single largest recipient of fossil fuel money in the US House of Representatives. They saw that as perhaps not an appropriate use of congressional authority. Now, it might not be surprising to you that a progressive Democrat like Henry Waxman, who, by the way, led the effort to bring the tobacco industry to justice back in the 1980s, 1990s, that he would come out in support of us and would criticize his colleague Joe Barton. But what I think might surprise you was that the biggest hero in this story turns out to have been another Republican, not a Democrat, a conservative, an old-school pro-science, pro-environment Republican, Sherwood Boehlert, who was also a powerful House committee chair. He was the chair of the House Science Committee. And he, again, used perhaps the harshest words, stopping just short of accusing his fellow Republican of engaging in modern-day McCarthyism. And he wasn't the only prominent Republican to do that. John McCain, who was the former candidate, a Republican candidate for US president, at the time wrote an op-ed in the Chronicle of Higher Education, where he said, "The message sent by the Congressional Committee to the three scientists was not subtle, published politically unpalatable scientific results brace yourself for political retribution, which might include denial of the opportunity to compete federal funds. It represents a kind of intimidation which threatens the relationship between science and public policy. That behavior must not be tolerated. Now, I don't know how many of you follow sort of American political history, but it's almost unprecedented in modern American political history to see one Republican call out another, a fellow Republican, in such harsh language. It was pretty remarkable. And so it turns out that hey, I haven't even said anything yet. So the attacks didn't stop there. In 2009, at a small little herd of university in the UK, the University of East Anglia. Well, in fact, I think you all have heard about this, haven't you? Thousands of emails were stolen from the University of East Anglia. These were emails between various climate scientists, including myself, and individual words and phrases were taken out of context and used to make it sound like scientists were fudging the data, like scientists were engaged in misconduct. And it was used, and again, I'm sure it was coincidence, that it just happened to happen in the lead up to the Copenhagen summit of December 2009, the single greatest opportunity, arguably, for progress in dealing with climate change in years, that instead this manufactured campaign, which became known as ClimateGate, spread through the conservative media and eventually into mainstream media outlets, particularly here in the UK. It represented a distraction. And we can discuss whether or not it had any meaningful impact on what happened in Copenhagen, but it certainly gave those looking for a reason to justify their inaction on climate change a talking point. Well, we just learned that the entire science of climate, the greenhouse gas that Joseph Fourier, the greenhouse effect that Joseph Fourier understood in the early 1800s, the measurements of CO2 in the atmosphere, apparently all of that was eradicated by the comments, the off-the-cuff comments between various climate scientists. And at the time, Sarah Palin wrote an op-ed in the Washington Post where, among other things, she said that these emails showed that experts were trying to hide the decline in global temperatures, okay, which is really pretty remarkable because the email she was talking about, some of you may have heard of this email before. It was from a colleague of mine in the UK, sent to me and other scientists. The email was written in early 1999. There was no decline in global temperature. Early 1999, we were on the heels of the warmest year we had ever seen, 1998, which was boosted by a big El Nino event. So there was no decline in global temperature to be talked about. What the email was referring to was an artifact that they had published about in the journal Science in 1998, where they had discussed how certain types of tree ring data become unreliable after 1960. They no longer track temperatures properly, and they shouldn't be used to depict temperatures after 1960. They talked about this in the journal Nature in 1998. That's what the article was about. And what this scientist was talking about is, hey, in this graphic we're preparing for this government report, we shouldn't be showing misleading data. We shouldn't be showing this artificial decline. It's going to mislead people as to the nature of modern temperature trends. And I explained this and a number of other things that Sarah Palin got wrong in my own op-ed in the Washington Post 9 days later. And I think it must have gotten through to Sarah Palin because just a couple years later, these are her own words, okay? She said a lot of those emails obviously weren't meant for public consumption. And she said they could be misinterpreted if taken out of context. Of course, she was talking about her own emails that had been released in response to a Freedom of Information Act request over time as governor. It didn't stop there. Okay, James Inhofe, who you'll remember from earlier, saw these emails as justification for prosecuting 17 climate scientists. Apparently, he couldn't come up with 57 climate scientists, like the character in the movie The Manchurian Candidate. But he was able to come up with 17 climate scientists who should be prosecuted for perpetrating the hoax of human-caused climate change as revealed by these stolen emails. I'm proud to say that I was among those 17, along with my colleague Susan Solomon, a recipient of the Presidential Medal of Science. And it doesn't matter that several years later, every investigation that had been done, depending on how you count, 9, 10, 11 different investigations, have all found that there was no impropriety, there was no fudging of data that was found, that was evident in these emails. The only wrongdoing that there's any consensus about is the criminal nature of the theft of the emails in the first place. Well, but that didn't stop at the time. Ken Cuccinelli, a newly minted Tea Party Republican Attorney General of Virginia. Now, I had been a faculty member at the University of Virginia from 1999 through 2005. And Ken Cuccinelli, in spring 2010, in his first act as Attorney General, had that's right. His first act as Attorney General, he wanted to change the state seal of Virginia because it exposed part of the anatomy of the Roman goddess Virtus. That was his first act. His second act as Attorney General of Virginia was to borrow a page from the Joe Barton playbook and use his authority as Attorney General to employ what's known as a civil investigative demand, a civil subpoena, where have we heard that before, to demand all of my personal emails from the time that I was at the University of Virginia, from 1999 to 2005. Now, this civil subpoena is reserved for the Attorney General to help ferret out state waste and fraud, typically Medicare fraud. But he reasoned that since I had been working on the science of climate change while I was at the University of Virginia, and clearly the science of climate change was fraudulent, this was a perfectly appropriate application of the civil investigative demand. Well, others didn't quite see it that way. The Union of Concerned Scientists, American Association of University Professors, the ACLU, even the conservative group, FIRE, that typically advocates against what they perceive as political correctness in academia, conservatives who recognize that it didn't matter what your politics were, whether you were progressive or conservative. The idea that an academic could find him or herself subject to what they saw as a witch hunt because they had an attorney general who didn't like their academic work. They recognized that was a threat, no matter what your politics are. That just isn't right. That shouldn't happen. And so his efforts were criticized by 800 scientists and academics from the state of Virginia. I didn't even realize there were 800 scientists and academics in the state of Virginia. Signed a petition demanding that he cease and desist in his efforts to intimidate, once again, scientists whose findings might be inconvenient to the special interests that happen to fund his campaigns. The AAAS, once again, National Center for Atmospheric Research, the American Meteorological Society, and the reliable journal Nature, all came out once again sharply criticizing what they saw as a transparent effort to intimidate scientists whose findings might be inconvenient to certain special interests. The Washington Post published no less, even the conservative Richmond Times-Dispatch editorialized against Cuccinelli's attack against us. And in fact, for the first time ever, this past fall, they did not endorse the Republican candidate for governor, which was Ken Cuccinelli. They made no endorsement. I ended up campaigning with his opponent, Terry McAuliffe, who is now the governor of Virginia and recently resurrected the Virginia Climate Board, of which I am now a member. Elections do matter. Well, the Washington Post, as I alluded to, they couldn't get enough of this. They wrote no less than 5 editorials denouncing what they referred to as Ken Cuccinelli's witch hunt. And even their award-winning cartoonist, Tom Tolles, couldn't resist weighing in on the matter, not once, but twice. And I have to say, this is my favorite. I don't mind being compared to Galileo, I confess. Well, it turns out that Cuccinelli's civil investigative demand was rejected by the lower court. On a technicality, Cuccinelli would argue. What they found was that in his 40-plus page filing to the court, he had failed to provide any evidence of wrongdoing on my part. Well, of course, he appealed the matter to the state Supreme Court, which rejected the case with prejudice meaning they really don't want to ever see an attorney general come back to the court with something like that again. It turns out that a front group funded by the Koch brothers tried to use a Freedom of Information Act to demand the very same emails. That went all the way to the state Supreme Court, which just earlier this year ruled against that group, that the private scientific correspondences between colleagues is protected discourse. And that turns out that will likely be a precedent that will be important as similar efforts work their way through the courts in other states. Those same groups are actually targeting more than a dozen climate scientists in a number of states now. Well, it would be easy to be pessimistic about all of this, given the politicization of the science, if it were not for the fact that we have folks like Sherwood Boehlert, who wrote an op-ed warning his party, the Republican Party, that if they continue to go down this road, they risk making the Republican Party, the party that he loves, the party of Abraham Lincoln, who founded the National Academy of Sciences, by the way, Republican. How ironic that the party of Abraham Lincoln, who founded the National Academy of Sciences, would become the party of anti-science. And that was what was at risk if the Republicans continued down this road. And fortunately, there's some evidence now that there's a bit of a cleavage forming within the Republican Party, pro-science Republicans who don't want to see themselves as anti-science, and have called for a meaningful discussion to get away from this charade of pretending that climate change isn't real, and to get on to the worthy debate. And there's a worthy political debate, and conservatives and progressives have every bit as right to be at the table, and we should be hearing about conservative solutions to the climate change problem. There's a very worthy political debate to be had about how we go about dealing with this problem. There's not a worthy debate to be had about whether the problem exists. So I'm hopeful that we will get on to having that worthy discussion. And the solution, there's no magic bullet. All the options should be on the table, even options that are unpopular with some. Should we price carbon, and if so, what sort of mechanisms? There are conservatives now in the US who have come forward and said, let's introduce something like a carbon tax, but we make it revenue neutral. There are offsetting taxes, so we don't increase the taxation on the American people. We just shift the taxes around that can be consistent with our conservative ideology. I think that's great. I think that's the sort of discussion we need to be having. Now, let me finally leave it on a personal note, because climate change is it's an issue we often frame as a scientific issue or an economic issue. We just run a cost-benefit analysis, and we can determine some optimal strategy for abatement, or a problem of policy or politics, as we've seen. But to me, more than anything else, it's a problem of ethics, okay? The ethical obligation that we have, in particular, from my perspective, to future generations, to not make decisions now that will guarantee a legacy of a degraded planet for our children and grandchildren. This is my daughter a few years ago. It's a polar bear. And let me make clear, we're not torturing our daughter here, because I'm sure this will be on a blog tonight. We're not torturing her. At the Pittsburgh Museum, you can walk through a plexiglass tunnel that goes underneath the polar bear feeding pool. And it is true that if you happen to be working on an NSF-funded project to develop climate change outreach materials for zoos and aquaria, and you know the manager of the zoo, you might be able to convince him to throw the fish in the pool when your daughter is walking underneath, which is what's happening here. But on a serious note, and it's not just about polar bears, as we've seen. I mean, they may be symbolic of a fundamentally degraded world that we will leave behind if we don't act in some way on this problem now. So I think I'll leave it on that note, and I'll be happy to field questions. Thank you.